Heute in Folge 51 habe ich Professor Dr. Claire Jacob zu Gast im Interview. Sie forscht über die Regeneration von Myelin und das Interview fand in Englisch statt, da sie Französin ist. Du kannst dir aber das Interview auch in Deutsch anhören, dann ist es allerdings nur von mir alleine gesprochen. Viel Spaß! MS-Perspektive. Hallo und herzlich willkommen zu MS-Perspektive, der Multiple Sklerose Podcast. Von und mit Nele Handwerker. Ich hoffe, dir gefällt der Podcast und wenn du auf dem Laufenden bleiben willst, dann abonniere doch gerne meinen Newsletter, den du auf meiner Webseite www.ms-perspektive.de findest. Der Newsletter ist natürlich kostenlos und bringt dir zum einen Informationen über die MS, um verschiedene Themen rund um die MS und zum anderen bekommst du auch einen kleinen Einblick in mein Leben. Today I'm very happy to welcome Professor Dr. Claire Jacob to an interview about her latest research outcome. Claire and her team understood the critical mechanisms that enables the regeneration of myelin. Quite spectacular, as this might result in healing of disabilities caused by MS in the future. Hello Claire, it's a pleasure to have you on the podcast.
Hello Nele, thank you very much for inviting me to participate in this podcast. I'm very happy to be online today with you and of course to answer your questions about our work on related to MS.
Yes, thanks a lot for your time. I know you are quite busy. So, you've been doing research since 16 years on the development of myelin, damaged axons, and how to regenerate them. What is your motivation for that? Was there any private relation to multiple sclerosis?
Well, actually, I've been always fascinated by the nervous system. So I wanted to know how it works and how it can control multiple functions like our thinking process, our movements. So this is why I chose to work on the nervous system. And when I started to work on it, I started to work on its development because I wanted to understand its functioning. So the nervous system is built of different cells. So there's some neurons and glial cells, and among those glial cells, they are the myelinating cells. And actually, those myelinating cells, as you very well know, they have a critical function for the nervous system. And why did I start to work on those cells? Actually, was to be honest, it was a bit by chance because I was a researcher in San Francisco working on chronic inflammation. But since I always wanted to work on the nervous system, I decided to change the field and look for a lab that would welcome me to work on the nervous system. And then I found a lab in Zurich at the ETH in Switzerland, the lab of Professor Willy Suter. And after discussing and meeting, Willy Suter invited me to work in his lab. And so his lab is very renowned in the field of myelinating cells. So that's how I started to work on those cells.
Mm-hmm. Okay.
Then actually, so that was the first step, and following that, a very short time after starting in the lab of Willy Suter, I had a big accident during a skiing trip. I had a spinal cord injury, and so I was paraplegic at this time, and I spent that was a horrible time in my life, I have to say. It took very long. I had very long rehabilitation, and I worked really hard with physiotherapists who are actually really fantastic people. And then during that time, when I was in rehabilitation, I made a promise to myself that if one day I can go back to the lab and do research again, I will work on regeneration. Mm-hmm. And actually, I managed to go back to the lab and start my own lab. And when I did that, when I started my own lab, then I started to work on regeneration of neurons, but also of myelinating cells. Since I was, after a few years in the lab of Willy Suter, I became expert on those cells. So that's a long story, but that's the full story.
Yeah, but it makes it more personal to you, I guess.
Yeah, actually, it increases the commitment, right? I have a very strong commitment to work on regeneration of the nervous system.
Absolutely, and I'm very glad you made it. I can believe that it was quite a hard time to get back to normal life without pain and being able to move normally.
Yeah, that was really a hard time, and I actually didn't recover 100%, but really remarkably recovered almost everything. So some minor sensory defect, but I have now a normal life with some. I cannot do sport, for example, but apart from that, pretty normal. So,
Okay,
yeah, I was
glad.
very lucky. Yeah.
Yeah. That's good. Okay, so just to get an idea, how many people are roughly part of this research objective? Are we talking about 10 people, 15, in the range of 100? How many people are working in your team?
So I have right now actually a very small research team. We are just 7. And yeah, the reason for that is that I recently moved my team from Switzerland to Germany, and I wanted to get the lab started with experienced people to get more efficient. So now we actually running well. The lab is running, and we're quite ready to increase to grow the lab. So we will soon get more PhD students and postdocs. So yeah, I don't think we will be more than, let's say, 15, because actually I really like to work in a small team, because I find it just more efficient and more satisfactory for me, actually, because I can directly supervise everyone, and like this we can really make important decisions and move fast. So of course now we will also organize clinical trials. So it means that the team will grow with medical doctors, biostatisticians, and also people from the regulatory field. So we will get a bigger team to hopefully reach our objective to make available a remyelination therapy for MS patients.
Mm-hmm. Okay, so just for our listeners to understand, there is a difference in the healing of myelin between the peripheral nervous system and the central nervous system. Could you explain that in a simple way? Because the listeners are not very often doctors, I guess, but patients.
Yeah, I will try to do my best to explain it in a simple way. I actually very much like to talk about the differences between the peripheral nervous system and the central nervous system. It's really a question that fascinates me and drives actually most of our research. So. So I have to start by telling you that the peripheral nervous system and the central nervous system are actually very different, because one of the main reasons is because simply they are built by different cells. So in the concerning myelin, the production of myelin in the peripheral nervous system, the cells that produce myelin are called Schwann cells. And they react to a lesion very differently as compared to the cells that build myelin in the central nervous system. So those cells in the central nervous system are called oligodendrocytes. So when there's a lesion in the peripheral nervous system, then the Schwann cells that actually produce the myelin around the damaged axon, they have the possibility to get rid of their myelin. So they actually digest it. They digest this myelin, and then they change their shape. They even change their own identity, and they become repair cells. And those repair cells, they're able to promote the axonal regrowth, so to help the axons to regrow after a lesion. So they guide them for their regrowth, and once they have regrown, then they wrap them again and they remyelinate them. So
I love
Those are fantastic cells. They are very plastic. They can sense the lesion, so they react very fast. So this is a reason why the peripheral nervous system can regenerate very well. And in contrast, in the central nervous system, which actually cannot regenerate very efficiently, if there's a traumatic lesion, the axons they will not manage to regenerate well. And so there are several reasons for that, but one of the main reasons is that the oligodendrocytes, so the cells that produce myelin in the central nervous system, will block the regeneration, the regrowth of the axons in the central nervous system. So in the peripheral nervous system, the Schwann cells, they help the axons to regrow, but in the central nervous system, the oligodendrocytes block the axonal regrowth. Okay. So that's one of the main reasons, not the only one, but one of the main reasons why the peripheral nervous system can regenerate better than the central nervous system. But this is, of course, it's not exactly answering your question, because this is to talk about the traumatic injuries. So when actually we talk about demyelinating lesions, such as MS lesions, it's not really easy to compare the central nervous system with the peripheral nervous system, because there are some demyelinating diseases in the peripheral nervous system, but they're very different to MS. So yeah, so I would say in the case of MS, what happens, as you certainly know, is that the oligodendrocytes that produce myelin, they are attacked and then they die. And that leads to a lesion, to a demyelinating lesion, so where there's no myelin anymore. And then the system has to reproduce this myelin. And so the cells that are known to repair the lesions, they're called oligodendrocyte precursor cells. And they actually live in the central nervous system of an adult, so they are present. And they can sense if there is a lesion somewhere in the central nervous system, and they migrate to the lesion. So they go there, and then they remyelinate. Okay. But the problem is that this mechanism is unfortunately not extremely efficient. So they can do it usually pretty well in MS patients at the start of the disease, or in young patients. But when the disease progresses and with age, then they lose progressively their capacity to remyelinate. So what we are trying to do in my lab is to push those oligodendrocyte precursor cells to remyelinate, even in aged individuals.
That is good, yeah. That is good, and hope.
I hope it was not too complicated.
Yeah, no, but thank you for that insight. I think it is possible to understand what you just explained.
Great.
So you need to push them to make them work harder, as they don't do it by themselves, at least in older patients.
Yes, exactly. Okay. Yeah.
So for MS patients, the central nervous system is the most interesting one where lesions happen and might cause disabilities after a while. You achieved great results in experiments regenerating the myelin in the central nervous system of younger and older lab mice. So you have already some very great results, even if it's mice. But hey, it's not that far away from human. So how is that healing process working, and what challenges did you have to overcome?
Yes, so yes, as I just said, so the oligodendrocyte precursor cells, they progressively lose their ability to become myelinating cells in MS patients and during aging. So what we did is that we looked for a way to push them to produce this myelin. And we went for after the most essential mechanism that induces myelination. So the very first mechanism is called the transcriptional program of myelination. So this transcriptional program of myelination enables the myelin components to be produced. So to produce that in the cell, So go to at the gene level and then make those myelin components being present in the cell, and then build the myelin. And of course, the challenge was it's quite a complex process. So the challenge was to understand the full mechanism, and it took us years and years of hard work, I have to say, to assemble the full process.
Yeah, I believe you. Quite a complex thing. And so you had already these great achievements with mice. So what will be the next steps for your research? What comes now?
Yeah, so my lab is focused on the understanding of the function of a certain type of proteins of enzymes that are present in the body, and that will, as I just explained, that will modulate the expression of our genes, so that will produce certain protein at the gene level. And so these enzymes, these protein, they are called epigenetic factors, or more precisely chromatin remodeling enzymes. So they go to the at the gene level, and they make space. Actually, they allow the production of those genes.
Okay.
So yeah, that gets a little bit technical there. So what we're gonna do is that we will continue our research on these enzymes, on these epigenetic factors. And our aim is to use them to improve the regeneration of axons and of myelin. And so I really think that these enzymes, the epigenetic factors, they're really a great source of potential new strategies to control the regeneration of axons and of myelin. So either in the context of traumatic injuries, or in the context of degenerative diseases such as MS.
Okay, yeah, because at the end it's about remelling. Hard word. Getting myelin back where it should be.
Yeah, exactly. And of course, in some cases, of course, of MS, when there's a lack of myelin for a long time, then the axons are also damaged. So also there, it would be very important to regenerate the axons.
So would there be a difference between someone who has it for a long time, that issue, or someone who has it just for a short time?
I would think so. So what we are trying to do actually now is to organize clinical trials in different contexts. So either in a chronic situation where the lesions are there since a long time, and then we are trying to remyelinate and to rebuild, or in acute situation where the patient just had a lesion and then we try to repair it. And we hope that at least in one case we can help the patients, and of course ideally in both cases. It would be great. Yeah, that would be great.
Great. So what else is needed in order to find a working solution for healing damages in humans? What will be the next things for you?
So the very next step now is for what we have just found is to collect enough money to organize the clinical trials, and so that will be the aim will be to promote remyelination in MS patients. And we have another type of clinical trials that we will set up, where actually we want to promote remyelination after traumatic lesion in the peripheral nervous system. So the first step is now to build a team. So we have started to build a team to organize the clinical trials and of course to get the funding.
Okay, yeah. So getting everything on track, or preparing, and then going in these two directions. That sounds great. Is there anything we as MS patients can do to support your research?
Yeah, well, as I said, what we need right now is really funding for the trial. So I think talking about this research is great. So if MS patients are in contact with potential donors or investors, they can just talk about it, make them aware of our research and of our need for funding. And so I think that's what is needed right now. And the earlier we will have the money, then the sooner we will be able to start the trials.
Sounds great. I will do that podcast as well in German with answers. So hopefully we can reach out to many people.
Yeah, that's great. And I'm sorry that my German is not yet at the level to.
You are totally fine.
I'm learning.
Yes, I mean, you speak French, English, and German. So you are good. Do you want to share any more thoughts with the listeners?
So I would really like to thank all MS patients who have contacted me so far. So many people contacted me. They showed their enthusiasm towards our work. So that gives me really a lot of energy to go forward and push this project. And so I hope we will manage. And I want to thank all the patients who give me all this energy. And of course, Nelly, I want to thank you for organizing this podcast. And that gives me the occasion to talk about the next steps of our work. I think this is very important.
Yeah. Thank you for all your hard work and of course your team. That's true. Those young people who work hard in the lab. Is it possible to stay tuned for your research activities? As I think it's still a way to go. But how can people who are interested stay tuned?
Yes, so people can always check my website at the University of Mainz in Germany, and then they can learn about our latest publications. And there is also on my website, there's also a section called News, and there I always add a short text to summarize our key findings for the most important publications, and I also link this little text to the corresponding press release, where it's a bit easier to understand than the publication for non-scientist people.
Yeah, I will put all these in the show notes. So
that's great. Yeah.
Listeners can just click.
Yeah.
Okay, so Claire, thanks a lot for your time and especially for all your efforts during the last 16 years. Quite a time. I know that research can be quite frustrating for my own boyfriend, soon to become husband, as he is a physicist. I know it takes many dead ends before finding a breakthrough milestone, and I do hope that you and your team will find a few more milestones down the road, and of course at the end a great result, a working solution, which I guess will still take some years.
Yeah, thank you, Nelly. Yeah, I hope so too. Really, I hope that we will manage for this treatment that we have found already, and then for the next one. So, as I said, we're continuing to work on that regeneration of axons and myelin, and more things are coming. But of course, now we need more work for the next project to in the lab. To really make sure that this has a chance to succeed. So, but we love to do that. I always choose people in my team who really love research and who are really committed. So even when the times are a bit difficult, solutions are difficult to find, we don't give up. So I'm confident that we will continue on a good track.
I'm pretty sure. Maybe we can have a second interview when there are some new lovely findings.
Yeah, that would be great. Of course.
I would love to welcome you here. So thanks a lot, Claire, for your time.
Thank you. Yeah, and and all the best for the wedding.
Yes, thank you. Bye.
Bye, Nelly. Bye.
Das war MS-Perspektive, der Multiple Sklerose-Podcast von und mit Nele Hanswerker. Wenn dich mein bisheriger Weg mit der multiplen Sklerose genauer interessiert, dann empfehle ich dir mein Buch mit dem Titel Multiple Sklerose, keine Angst, ein 15-jähriger Erfahrungsbericht. Vielleicht hast du auch Interesse an meinen Kinderbüchern. Ich habe sie alle unter meinem Namen Nele Hanswerker veröffentlicht. Du kannst jedes Buch mit persönlicher Widmung von mir direkt bekommen oder du bestellst es in einer Buchhandlung deiner Wahl bzw. im Onlinehandel.